Hi everyone. So today we're looking at graphing these equations that we talked about yesterday. Yesterday we talked about linear equations in slope-intercept form. Today we're going to remember how to graph these. And I say remember because I'm pretty sure that you guys have learned this before, like probably 8th grade. So I'm going to probably go very quickly through these first two examples. Remember that the beauty of this being on a video is that you could always rewind it and watch it again if you're confused. So if I want to make a graph of this line, y equals 3x minus 2, I'm always starting at the y-intercept. Okay, and if you remember yesterday, we said that the y-intercept is like the initial value, so that kind of holds true here too. So my y-intercept is negative 2. The y-intercept will always belong on the y-axis. Always, always, always you will find it on the y-axis. So I'm going to put a dot right here at negative 2. And then my slope, this tells me where to go after that, my 3. We want to think of it as a fraction because slope is a ratio of vertical change to horizontal change, otherwise known as rise over run. So from that negative 2, we want to rise 3, which means go up 3, and run over to the right positive 1. And then we can just continue that pattern. So up 3 and over 1, up 3 and over 1. Just do it a couple of times so that you can make a nice straight line. And we can draw our line in there. Okay, let's look at the next one. So for the next one, let's think about where we're going to start. We're going to start at the positive 5. And again, that's on the y-axis. So 1, 2, 3, 4, 5. Now the slope on this one's a little trickier. Our slope is negative 2/3. So we have to decide, does that negative belong on the top or does it belong on the bottom? Okay, that's kind of a trick question because you could put it either place. This is the same thing as negative on the top, positive on the bottom. I guess I should have put an equal sign instead of an arrow. It's also the same thing as positive on top, negative on the bottom. All three of these things that I wrote right here are exactly the same, okay? This is not the same as a negative on the top and the bottom because the problem is with a negative on the top and the bottom, they would cancel each other out and become positive. So you do not want to do this, okay? So negative on the top is fine, negative on the bottom is fine, just don't put it on both. If I have it up on the top, a negative for my rise means that I'm actually going to go down 2. And then positive for my run means I'll go to the right positive 3. So down 2 and to the right 3. Down 2 and to the right 3. Okay? If I were to go this other way and I have a positive rise, that would mean that I would go up 2. But then with a negative on my 3, that would send me to the left 3, and my point would end up right here. And then I could do the same thing, up 2 and to the left 3. But then notice that's all going to end up on the same line. So that's why it doesn't matter which one of these you do. They're all going to end up in the same location. Okay? So that's what that graph would look like, except that should be a little straighter, but ignore that. Okay. So that third example, there's an issue with this one, okay? The problem with this one is this is not in slope-intercept form. To be in slope-intercept form, we would want to get the y by itself. We want to get it to look like this, y equals something. So we need to move this equation around and solve for y. The first thing I would want to move then is the 3x. So let's subtract 3x from each side. Now over here on the right, when I say subtract 3x, we can't actually subtract 3x, right? I can't do 12 minus 3x because with an x, those aren't like terms, okay? I could just write it as 12 minus 3x, but because in slope-intercept form the x comes first, I'm actually going to take this negative 3x and kind of squeeze it in front of the 12. So here's what that's going to look like. Negative 4y equals negative 3x plus 12. That kind of throws people sometimes because they think that that 12 should be a minus since we're subtracting. But notice this 12 that we started with up here is positive. So you still want it to be positive down here. We're just putting the negative in front. And then we're going to divide by -4. And just make sure you divide each piece separately by -4. So we end up with y equals, actually I'll just rewrite down here. You almost can't see that, can you? Sorry about that. There we go. Y equals, here, this doesn't divide, right? And I'm just going to leave it as a fraction because we like it when slopes are a fraction. But two negatives make a positive, so I'm going to make it +3/4 x, and then 12 over -4 is -3. And so this is an equivalent version of this, and it's in slope-intercept form. So I can graph it by starting at -3, and then rise over run tells me to go up 3 and over 4. Up 3 and over 4. And there's my line. So anytime your equation is not in slope-intercept form, right now, this is your only option, is to rearrange it to slope-intercept form. And quite honestly, I'm going to show you later another way to graph something that looks like this. But even after I show that to students, a lot of the times they still stick with this. Okay, it's what they know. Okay? Okay, moving on. Next part of our lesson for today. Up here I was just going to remind you. Finding slope if you've got two coordinates. So if you're given like, coordinate 1 and coordinate 2, we can find slope by doing y2 minus y1 over x2 minus x1. And I don't even think we really need to do a example of that because we've done so many of them in in chapter 2, I should say. So I'm good with just kind of leaving that there for you for reference. What I was going to say a second ago is the next part of this lesson goes into parallel lines. And I had a whole exploration activity built around this one here. But I don't think we need it because I bet that most of us remember what we need to know about parallel lines. Okay? Parallel lines have equal slopes. If two lines are parallel, their slopes are exactly the same. Okay? So when I see a question like this, example 4, write an equation for a line that's parallel to this one. The only thing I care about in this equation right here, the only reason that equation is even there, is if I want to be parallel to this line, I want to have this exact same slope. This is the only number that I really care about in that equation. The +6 doesn't mean anything to me. And I want my y-intercept to be -2, so that's my b value. And so then I can just write my equation using this m and this b. So y equals 2/3 x minus 2. And that would be my final answer. Okay? All right. So kind of going along with parallel lines, we have perpendicular lines. Perpendicular lines, just to remind you, are lines that cross at a 90-degree angle. Okay, so parallel lines are lines that don't cross at all. Perpendicular lines cross, but they cross in a very specific way. Okay? And when we're doing perpendicular lines, their slopes are what's called opposite reciprocals. And I find in math, sometimes people use these words sort of interchangeably. They think that opposite and reciprocal mean the same thing, but they actually mean two very different things. In math, opposite is talking about plus and minus, okay, positive and negative. Okay, if it's positive, turn it negative, vice versa. Reciprocals are like when you're working with a fraction and you flip it upside down, okay? So we switch the sign and we flip it upside down. That's how we make a line be perpendicular. I'm going to throw in just a quick example of that. So for example, if you had the fraction 2/3 and we want the opposite reciprocal, the opposite would be negative 2/3 and the reciprocal would be that flipped over, so it would be negative 3/2. Okay? So that's how you would turn a 2/3 slope into a perpendicular line. Just as another quick example here, if you had a slope of negative 5, okay, the opposite would be positive 5, but then let's think about the reciprocal. Remember when I have this 5 just sitting here, it's really over like a pretend 1. So when I make it a reciprocal, it's just going to be 1/5. Okay, so the opposite reciprocal of negative 5 would be 1/5. All right, let's put that into practice here. Write an equation for a line that's perpendicular to y equals negative 3x minus 2, has a y-intercept of 4. Again, the only thing I care about in this equation right here is this slope. I'm just going to borrow that slope from my equation. And I'm not even going to use the exact same slope. I'm going to take that negative 3, and I'm going to do an opposite reciprocal to make it perpendicular. So opposite would be positive 3. Reciprocal would be positive 1/3. That's going to be my m. Over here, I have a y-intercept of 4, so that's going to be my b. So I'm going to write myself a new equation that says y equals 1/3 x plus 4. Okay? And this equation would be perpendicular to this one, and it would have a y-intercept at positive 4. Okay, 2 more quick things and then we're done. Let's think about these lines that only have one letter in them instead of 2. So for example, y equals just the number 2. If we were to think about this in like an XY table, for example, what this is saying is x can be anything you want, y always has to be 2. Okay? So x could be a nice happy whole number, x could be a negative number, x could be 0, x could be a decimal, x could be something really, really hard, or not hard, sorry, really, really large, I should say. Okay? And no matter what x is, y is always going to be 2. So if we graph these points here, all right, 3, 2 would be here. Negative 5, 2. Oh, I think I lost count. Would be here. 0, 2 would be here. 1.4, 2 would be somewhere here-ish. Negative 654, 2 would be way down here, but it would still be 2 points up. And so really what I want you to see here is that all of these points fall along a horizontal line. Okay? So anytime you have just y equals a plain old number, that is going to be a horizontal line. Okay? Always going to be a horizontal line. And this is the mathematical reasoning why, but the faster you can just associate these two together, the faster you can kind of memorize that, the better off you'll be. Okay? Also, if it's a horizontal line and it's flat, it has a slope of 0. Okay? And we could prove that using these points if we did the slope formula, but I'll show you that probably in class sometime. Okay, let's look at the graph x equals negative 4. Same idea here, except this time y is allowed to be anything it wants. Y could be positive, y could be negative, y could be 0, y could be a decimal, y could be something huge, like, I don't know, 289. And no matter what, x is always going to be negative 4. So let's think about what that's going to look like on a graph. Let's see, negative 4, 3, negative 4, negative 6, negative 4, 0. negative 4 comma 1.7, negative 4 comma 289 would be way up here, okay? But what you should see here is all of these points fall along a vertical line, okay? So anytime you have an x equals equation, that's going to be a vertical line. And the slope of this one's a little bit weird. This slope is what we call undefined. And again, mathematically, if you were to calculate the slope using these coordinates, you would see why it's undefined. But I think we'll save that for kind of an exploration in class. So here, these three pieces of information go together. Anytime you have an x equals a number type equation, it's a vertical line with an undefined slope. And anytime you have a anytime you have a y equals a number line, that's going to be a horizontal line with a slope of 0. And really, it's going to be best for you if you can just associate these three things in your mind, all right, kind of memorize it, and then kind of memorize these two. We've talked about the math behind them, but you want to get to the point where you can just very quickly know that when you look at an equation like that, it's a horizontal line. Okay, I talked as fast as I possibly could, hopefully not too fast. Remember that you are welcome to rewind back to any part of the video that you may have missed. Homework for tonight is section 3.2 out of the textbook. I will post a PDF of some graph paper, so if you would like to use some graph paper for your homework, you are welcome to print it on your own. Otherwise, I really don't mind if you just kind of sketch the graphs in there, okay? All right, that's it for me. Thanks a lot. Have a good night.